When the current through the gap is comparatively large, it is of advantage to slip on the points of the discharge rod's pieces of very hard carbon and let the arc play between the carbon pieces. This preserves the rods, and besides has the advantage of keeping the airspace hotter, as the heat is not conducted away as quickly through the carbons, and the result is that a smaller EMF F in the arc gap is required to maintain a succession of discharges. Another form of discharger, which may be employed with advantage in some cases, is illustrated in Fig. 3. In this form, the discharge rods DD1 pass through perforations in a wooden box B, which is thickly coated with mica on the inside, as indicated by the heavy lines. The perforations are provided with mica tubes MM1 of some thickness, which are preferably not in contact with the rods DD1. The box has a cover C, which is a little larger, and descends on the outside of the box. The spark gap is warmed by a small lamp L contained in the box. A plate P above the lamp allows the draft to pass only through the chimney A of the lamp, the air entering through holes OO in or near the bottom of the box and following the path indicated by the arrows. When the discharger is in operation, the door of the box is closed so that the light of the arc is not visible outside. It is desirable to exclude the light as perfectly as possible, as it interferes with some experiments. This form of discharger is simple and very effective when properly manipulated. The air being warmed to a certain temperature has its insulating power impaired, it becomes dielectrically weak, as it were, and the consequence is that the arc can be established at much greater distance. The arc should, of course, be sufficiently insulating to allow the discharge to pass through the gap disruptively. The arc formed under such conditions, when long, may be made extremely sensitive, and the wheel, draft through the lamp chimney A, is quite sufficient to produce rapid interruptions. The adjustment is made by regulating the temperature and velocity of the draft. Instead of using the lamp, it answers the purpose to provide for a draft of warm air in other ways. A very simple way which has been practiced is to enclose the arc in a long vertical tube with plates on the top and bottom for regulating the temperature and velocity of the air current. Some provision had to be made for deadening the sound. The air may be rendered dielectrically weak also by rarefaction. Dischargers of this kind have likewise been used by me in connection with a magnet. A large tube is for this purpose provided with heavy electrodes of carbon or metal, between which the discharge is made to pass, the tube being placed in a powerful magnetic field. The exhaustion of the tube is carried to a point at which the discharge breaks through easily, but the pressure should be more than 75 millimeters, at which the ordinary thread discharge occurs. In another form of discharger, combining the features before mentioned, the discharge was made to pass between two adjustable magnetic pole pieces, the space between them being kept at an elevated temperature.